I'm Matt Godbolt. I am mostly a C++ programmer, although I spend most of my time writing Python these days, but that's a whole other story. I am most well known for my JavaScript BBC Micro emulator. Maybe not, actually. Maybe it's the other thing. Yeah, I'm most well known for Compiler Explorer, obviously. Yeah, no, sorry, Ben's saying gallery view. Yeah, it disappeared as soon as I started sharing my screen, the whole panel. Anyway, doesn't matter. So I'm going to be staring at you or a disembodied camera today. So I am doing this talk at C++ France in the beginning of December, and I really appreciate your feedback on what things are working in this talk, which things aren't working in this talk. For those who are watching on a recording many months later, you can have a laugh at how unprepared I was 2 weeks out from a major conference. So yeah, CPPP, PPP, as Jason says. So, but anyway, today I'm going to be talking about what C++'s superpower is. And if you want to have a quick think about what you think C++'s superpower is, I'll be interested to know how different my choice of its superpower is from your own. Oh, and of course, what I might need is a way of advancing the slides by having focus in the right window. There we are. So obviously, C++ is amazing. That's why we're all here. We're all talking about C++. There are loads of things to like about C++. But what would you pick? Here are some ideas about what I thought most people would pick if I said, hey, what do you think C++'s superpower is? You know, the first thing is it's ubiquitous. We've already heard today, there are people who are in the robotics industry. I work in finance. There are embedded systems. There are huge web search engines, everything, you know, that are written in C++ because it runs everywhere. I've got like an Arduino knocking around under here. I can write C++ for it. Mainframes, you can run C++ on. It's just fantastic, right? It's everywhere. So that could be it. It could be its superpower. It could be the performance, right? Many of the reasons that you can run, most of the reasons that you can run C++ on devices that are as small as little Arduinos and things is because the performance is great. You can write things that are extremely performant. You can have a decent understanding about where the cycles are going to go. The optimization is pretty transparent to you. If you want to, you can drop all the way down to assembly if you want, or you can go as high up as, you know, huge, big algorithmic improvements, which draws us to the next point, which is it's a multi-paradigm language. You can choose to write boring procedural code like I do most of the time. You can write functional code, you can write object-oriented code, you can mix and match, which also is kind of cool. Most other languages have a pretty strong opinion about how you should write code, and you can only write it that one way. Or the other thing that people are posting in the chat that you can't see is to do with deterministic destructors, which is clear object lifetime. You know, that is, honestly, if someone had asked me before I thought about this talk, I would have picked that as its superpower, right? It's great that it's performant. It's great that it's multi-paradigm. But what I really get is the fact that I know when my objects are going to die, and that means I can give behavior to that is meaningful. I can have my database connection closed. I can have my file closed. I can have the memory associated with my object cleaned up. And that's just great compared to many other languages that are out there. It's not unique to C++, but it certainly is a superpower. And to the best of my knowledge, it brought in to the mainstream the idea of like this RAII type thing. But maybe if we can't agree on what C++'s best feature is, we can perhaps look at some of these worst things and discuss those as well, right? You know, can't have the good without the bad. So it can't be, you know, undefined behavior is not a superpower. Having the wrong defaults, you hear people complain about this all the time. It's got legacy going back to like the beginning of time, it seems. And so that's partly why we have all of these wrong defaults. And because of the legacy, because of the choices that were made before, we have some confusing syntax. We're very lucky that we've been able to recycle some keywords over the years, and now auto means something different than it did in like the 70s from C. But you know, these are not superpowers. But I am going to try and argue today, and you can be the judge at the end of this, that the wrong defaults and the support for legacy are in fact C++'s superpower, because it gives us backwards compatibility. And I'm going to give you an example of backwards compatibility. I'm going to try and make you care about it. I will give you a worked example of why I think it's cool. And then at the end, I'm going to try and convince you that this is actually something that you should care about right now. So my goal is in this talk is I'm going to take some old code, or at least old by my standards, 25-year-old code, and I'm going to port it to modern C++ 17, which is going to give us the whole gamut of experiences from taking up code that has largely been untouched for 30 odd years and bringing it forward. And it's going to be sort of idiomatic C++ 17. That's not that surprising so far, but what I can do that I think is relatively unique to C++ is I can do that incrementally. In some cases, I can do that line by line. I can take a single line of code that was written in the 90s, and I can turn it from old style code to very up-to-date code. And we can just keep on running and executing and making sure everything works just by having changed one line. And I don't think you can do that in many other languages. And then I want to try and say why that's important. I want you to kind of go away with thinking that that is a good thing and not just a sort of terrible holdover from the past of C++. So the first question you might have is like, where are you going to get 25-year-old code? And that's a great question. What was happening in 1996? I mean, some of you may not even have been born in 1996, which is, I'm going to reveal rather too much about my age than perhaps I should do. So the first thing about 1996 is you should know that the Spice Girls had just released Wanna Be, and that's a very formative piece of music in my and group, in fact, in my life. USB had just been introduced, and so the beginnings of the third 180-degree rotation is required to get something to be plugged in was beginning to cement in our minds. And and actually bringing some quantum mechanics into the world. I don't know if you've ever studied quantum, but there are some particles, elementary particles, that need more than one complete rotation to get back into the same state. And I believe USB was the first mainstream application of this. And in 1996, I was at university studying for a degree in physics, which was maybe a mistake. I haven't ever used my physics degree. Never mind. So in 1996, I was at university and I was just starting to understand and learn C and C++. And I'm seeing some other people that are joining me in the chat here saying that, yeah, Ben, I was writing terrible C in 1996. Well, you're about to see mine, mate, because I was infatuated by this cool new concept called MUDs. Now, some of you have never heard of a MUD, I'm sure, but a MUD is a multi-user dungeon. So if you remember those text-based adventure games that came out in like the 80s and 90s, where you would just get a textual description of where you were in a game, and then you would say, go north, or take item, or open door, or kill monster. That's what a MUD was, except that it was multiplayer. So if you've ever played World of Warcraft or EverQuest or any of the more contemporary ones, I'm showing my age here by the fact that I can't think of anything more contemporary than World of Warcraft, you have sort of played the same idea of EverQuest, the same idea as a MUD, except that the MUD had to do it all with just ASCII text on a screen. So it was a multi-user game. It was text-based, based on Dungeons and Dragons. And yeah, you would sort of walk around, type north, south, east, west, whatever, and then people would move in. You'd see like, Bob enters from the west and that kind of stuff. And the way you played it was with just a raw TCP client. You could just literally telnet to a port on a computer and log in, and off you go, play with your friends. And that was a lot of fun. And it was so fun. First of all, I was playing this with my university friends. And then a couple of years into my degree, which was rapidly getting worse, my grades were getting worse, I decided that we would actually run our own MUD. So with me and a couple of my friends that we lived in a house together, we wrote a MUD. Well, I say we heavily adapted some source code that was available to us. So there was no GitHub back then, but you could get tarballs of code. And so we were able to get hold of someone else's MUD code and eventually kind of cobble together our own modifications to it, our own areas, our own content. And this was 2000. You can see there's some, unfortunately, the Wayback Engine hasn't been able to get all of the images back. I probably have them somewhere. And so this is what a MUD looks like. It's just a bunch of text and you type and you're looking around or whatever. And I'll show you a bit of this in a second. People talking about graduating in 95, making me feel actually quite young now. So thank you all. So what is a MUD really? A MUD is a giant text processor. It takes all of the text that people are typing in and their various TCP connections, It decides what they've typed in. It updates the state of the world. And then it sends out text that says, hey, yeah, you're now in this room, or no, the monster hits you for 10 damage, that kind of thing. Obviously, text processing is not C's, as this was mostly C. It's not its strong suit, right? I think we can all think of all the horrible butter overflow type things that can happen in C. So you might imagine that a more appropriate language might have been something like Perl, if you can remember back to that, or something similar. The issue was that the machines that we were running the MUDs on at those days were like 200 megahertz Spark workstations that like 100 people were logged into. And so performance was really important to us back then. So a lot of this was kind of handcrafted C code to try and get as much performance as possible out of this 200 megahertz machine. So we were kind of stuck with C, but we were dealing with a lot of text. So you're going to see some really choice code today as we slowly move things forward. Let's get some groundwork. If I'm going to take this old code and bring it kicking and screaming into the 2020s, I'm going to need to find it, first of all. Now, this is a slightly revisionist version of what actually happened because, of course, I discovered it accidentally. I didn't go and search for it, but I'm a kind of digital hoarder. I still have all the hard disks I've ever had in a big box downstairs in my basement. And so the first thing I had to do was dig out the source code. This was about 1.5 years ago. The code once I just got rid of all of the PII that we still had, we had loads of player files and things that really I had to get rid of. Obviously, there were people's records and whatever, and they were all plain text because we didn't know any better. We have somewhere in the region of 50,000 lines of C, and we were just starting to dip our toe into this newfangled C++ thing. There was a third-party library sort of chat bot that we had taken the code of, which was a couple of 100 lines of C++, and then I was just starting to write a bit of C++ myself. So we have about 700 lines of C++ in this code. And there are actually slightly more lines of Perl and make, which just goes to show how much gluing together this thing took. So before I even talk about bringing this code base from 1996 through to 2017, I suppose, for reasons that I'll get to, I didn't quite get to C++ 20. But before I even started on this, I want to try to clean out what we had. So the first thing I did was I checked the whole thing into Git so I could keep track of what was going on. I deleted all of the horrible make files that I'd written and replaced them with CMake, not because I think it's that much better, but honestly, because then I can load it up in my IDE a lot easier. I Clang formatted all the source code because there was a mishmash of every style you could possibly think of, spaces mixed with tabs and all sorts of other, horrifying things to see. I turned on all the warnings and I turned on all the sanitizing options I could possibly throw out. And I'll be honest, actually, I'm going to gloss over this for this talk, but at this point, there were a number of things that I found immediately in the C code. Most of those, in fairness, were things like signed shifts where, the bit masks were being used as sign numbers and shifted up, but none of them actually had any side effects, but it was worth cleaning out the campground beforehand. I brought in Conan, so I had a package manager of sorts. So if you don't know what Conan is, it's one of the two major package managers that we have available, the other one being VC Package. And what Conan allowed me to do is to later on easily bring in packages like FMT, like Ranges v3, like the test system Catch2, and so on. Basically, I brought the whole thing up to date with how I developed my modern C++. And obviously, having done all of this, I ran the code, I tested it. And it's worth saying that at this point, the test suite was me logging into the MUD, creating a character and running around and, killing things or whatever. Yeah, people are saying like tabs mixed with the spaces is the true democracy. That is true. I've got some stories about that we can talk about over drinks. All right, so now we're going to do a demo, and I'd just forgotten that this was what was going to happen next. So you get to see me looking slightly shocked. So I'm going to telnet to the MUD and log in as my test character, not my main character. And does your terminal support ANSI color? Actually, let me maximize this so that you've got as much chance as possible of seeing everything. The glory, the absolute glory of this. And yes, it does. So I've just logged in and I am standing where I left my character before. Oh, and apparently the sun has just set, which I'm sure we're all feeling a little bit here. You can see that I get a description of where I am. I can see the exits and I can look and it tells me all those things again. I can drink at the fountain. So let's drink and it says my thirst is quenched. I can look at my score. I can see that I'm a level 12 orc. and you know, I've got this much health points, all that kind of stuff. Oh, someone's just moved in. Now this is actually a non-player character, which you'll hear me say as being a mud. Sorry, no, as a mud, as a mob. Sorry, I've got mud on the brain. Mobs are kind of the name for any of the mobiles that can move around. Anything that's a character is a mob, and that's just a scripted character that wanders around and talks to people and whatnot. And obviously I can move backwards and forwards. I can look at the city guard here, and I can say, maybe I should kill the city guard. Shall I consider, could I kill the city guard? Would that be a good thing? And he says, do you feel lucky, punk? That sounds like it's a bit dicey, so I couldn't do that. If I can quickly, this is the problem with doing unscripted stuff and with a genuine thing that's changing. There's a rat here, so I'm going to kill the rat. Now, normally this would be many rounds of combat, but I'm level 12, which is not very high. The rat's like level 1, so the rat's going to die immediately with me trying to kill it there. But normally you'd see it kind of go back and forth, and I could flee or I could parry, and I get some stuff like that. So that's what we're talking about here. We're talking about, you know, a very simple multiplayer, and by multiplayer I mean looking in. There is me logged in, and then this is also me logged in from the terminal that you can't see on the other side, which is the immortal account there. But the eagle-eyed amongst you who are bored and probably noticed how to log into it and saw the telnet address, and I'm surprised that no one else is logged in yet. Anyway, I will come back to that at the end if there's people who've got questions. So that's what we're talking about. That's what the mud is. And at the moment, yeah, my test situation is I have to log in and I have to run around a bit and kill some mobs and just hope that nothing broke. Obviously, a lot of that code was C, and we're going to turn it into C++. So the first thing we're going to do is rename all the files that are C to be CPP and all of the header files to HPP. And obviously, it should just work, right? Well, let's have a little quiz. If you were to draw the Venn diagram of overlap between C++ programmers and Dungeons and Dragons enthusiasts, what would go in that middle section there? I'm going to give you like 10 seconds for anyone to type in what they think might go in there. Yeah, yeah, people are saying themselves. Awesome answer. Awesome. I thought this was the same circle. That's it. Lost dreams. There's some great answers. This is great. I hope I get this when I give this presentation later on. But the one word that goes in there is the word class. So this is what the code looks like in, of course, Dungeons and Dragons. Your class is whether you're a mage or a cleric or a wizard or any other number of things. So the number of variables that were called class were pretty high. And of course, one of the few things that break between a valid C program and, the very few things that are valid C that are not C++ are things that use the new keywords. And there aren't many new keywords. But yeah, exactly. People are saying just change class to capital letter class and things like that, which was kind of what we did. Also template, and there was enough string templating going on that there was at least one parameter that was called template. There was no usages of the word namespace, I'm glad to say, but I think those are the three main keywords. I'm sure someone's going to type in the chat the other keyword that I've forgotten that's not valid. Oh, that's unhelpful. Oops, no, that's not what I wanted. Ah, that is, thank you. That's... Well, that's great. Thank you, Ubuntu notifications. Okay, so you know we had to do a little bit of renaming at the beginning just to get ourselves. The C code didn't use co-yield. Thankfully, not. No. So I'm going to go on to my process, my general process here, which is the same as my general process when I'm developing code normally, which is I want to make a smaller change as is reasonable. I want to be able to write tests for that. Or in the case of the code right now, I'm just going to have to test it myself manually. And then because I want to make iterative process changes, small iterative changes, I'm going to give myself a lot of leeway to not make huge sweeping changes, not pull too hard on the threads if I notice something else that ought to be changed, but instead I'm going to leave a little note to myself, a little to do in the code so that I can make the smallest useful change possible that can be tested and checked in before I move on to the next thing without losing track. I mean, I'm sure you've all been in situations where you're editing code and you start going, oh, this isn't const correct. Oh, no, there's that. Oh, no, there's that. And obviously sometimes you have to pull that thread all the way through, and particularly const correct. But in other cases, you might just go, I'll do that later, right? One thing at a time. And that's what we're going to see today. So I've come up with some new acronyms here because acronyms apparently are the cool new thing. TDD down here is test-driven development. And we'll talk about that at the end. That's our goal. We want to get to sort of test-driven, or at least test-supported development as we go. But we're going to move through 2 intermediate stages, which you're probably already doing. You just didn't know that they had cool acronyms. And one is SAID, and the other one is GROUNDWORK. I'm working on the name, so give me some time on that. We'll get to what they are when we get there. Otherwise, it won't be fun. So here's the first bit of code we're going to look at. And we're going to spend a bunch of time looking at this one small struct from the C code, and we're going to bring it forward to fairly idiomatic C++ by the end. And again, the key here is we want to do it as small changes as possible so that I can still run my whole code base and be totally sure that it still works. So what's wrong with this structure? Ben has worked out one of the acronyms. Foremost Ben, right? No spoilers. Well, he's already spoiled it in the chat for you folks. So this is a structure which represents the area data, and what area data is like a suite of rooms, monsters that go in those rooms, and the objects that come from those rooms. It's like a single file. All of the files are like they're text files that we load. There's kind of a format for these things that the various MUD authors would swap and share. So you could like write your own set of rooms and objects and monsters and whatever.
Hey, Matt.
Yes.
For some reason, your gain just drastically changed all of a sudden again, and a bunch of people commenting on it as well. I don't know what happened, but you were like quiet.
I can guess what it is because I accidentally clicked that thing, didn't I? So you can all have a laugh at me.
It was while you were talking. It was very weird.
All right, I'm going to put that back there. Is that more like it?
Yep.
Okay, thank you, everyone. That's not happened to me before. Famous last words. So when it happens again, oh, that's true. I might have had a some kind of AGC, excuse me, AGC thing going on. Maybe because I've got Audacity open. Hang on, let me turn Audacity off. Sorry, everyone. Oh, and that's going to go away. You get to see, yes, save the thing. Yes, save, sure, whatever. Go away. All right. Sorry about that. Okay. Oh, it's a bug that happens in Zoom, says somebody. All right. Well, if it happens again, please let me know. And thank you for dropping in, Jason. So yeah, this area data is the metadata about a bunch of rooms, monsters, and objects that go together logically. And I've elided the rooms, the monsters, and the objects just to kind of concentrate on this structure. So let's see how we could improve this struct. Well, if I had focus in the right window, well, the first thing we noticed, or the first thing I noticed, was that it's in a hand-rolled linked list. Obviously, C code, as it came from, didn't have the wonderful STL that we come to rely on. So all of the dynamically allocated structures, such as things that were loaded from files, were allocated with malloc, and then in order to make containers out of them, they were all put into singly linked lists. So we can improve on that. We've got these horrible mutable strings. I mean, they're not just mutable in as much as you can change where the pointer is pointing, because you can reach into the area data and move it around. It's pointing at a mutable block of chars. And that means that I don't know, do I own them? Can I change them? Should I be freeing them when I die? How many bytes over the end of them can I do? Should I even be able to change them? I don't know. There's no clues there. And so it's a bit of a dangerous thing to have a regular char star. And not only that, they're C style, right? So, I mean, that means that I am going to be responsible for cleaning these things up if I am indeed the owner of the memory that they point at. So we can fix that. There's this funny thing to do with a type def, and there's this struct area data, which is like a holdover from C. So in C, if you type struct blah, you forever have to refer to that struct blah as struct blah. We're used to C++, where if you say struct blah, now blah is like a new name that you can use. In C, that wasn't the case, but you could use a type def to mean, oh, whenever I say area data in shout caps, I mean struct area data. So that's unnecessary. We can get rid of that. There's a horrible global down the bottom here, which is referring to all the areas. That's not very nice. Obviously, there's no encapsulation at all here. It's just a naked struct that anyone can look at and any other part of the code can manipulate, which doesn't seem very nice. Certainly for testability, I can't make any real claims about how closed off this particular class is. Erudite area data, that's awesome. there's a yeah, right. I'll try not to look too much at that, otherwise I'll be distracted by all of the cool things being going on in the text. So let's start with the simplest possible thing we can do. So we already have the code it's building. And what we're going to do is we're going to change struct area data into struct area data and get rid of that type def, right? Simple change. As it happened, that was literally the only thing we had to do, was to get rid of the type def. And then in the few places where I was saying the old style struct area data, just replace it with regular old area data in shout caps. That's a horrible name, and we're going to change it later, but we're trying to make minimal changes here. So most of the code didn't change for this. It was like 3 lines of code. We build, we run, I go through my horrible manual testing, right? So far, so horrible. So far, we know what's going on there. But we're going to hopefully get to somewhere that's a little bit more justifiable, not justifiable, I don't know, sustainable, because I don't want to keep logging in and killing the same monster over and over again. Let's move on to something a little bit more meaty, but not much more meaty. I want to change a single element. I'm going to change a single element from a C-style idiom to a C++ idiom. So I'm going to pick on the name, and I'm going to change it to a standard string. So this is our very first bit of C++ code in this whole code base, ignoring the small bit that I've done before. But now we've got some C++ in the main code of this game. So now I move on to my first acronym, which I'm very pleased that Ben hadn't guessed. CEDD is compiler error driven development, which is how we actually refactor, as I'm sure you all done. So I'm just giving a name to an existing practice. And in fairness, actually, when I was talking with a friend of mine, he pointed out that anyone who's seen Michael Feathers' books on dealing with legacy systems, he has this concept of leaning on the compiler. And that's exactly what we're doing here, is we're going to change something, and then we're going to wait for the compiler to tell us where we need to change something else, right? We've all done that before. Isn't that how we template metaprogram? I'm sure it is, yeah. So the problem with changing something like that is that you can't always be guaranteed that you're going to get a compiler error. So I wonder if you can see what might happen here, having just changed our char star name into a standard string name. Somewhere later on, we've got this horrific C-style printf nonsense that's going on. And, printf doesn't know what we're doing. We've got a %s there, and we've just passing it in what was a char star, but now it's getting a whole standard string. Something horrible is going to go wrong here. Now, if I was giving this talk 10 years ago, I would reasonably just say, oh yeah, there's a corruption on the screen. You get any amount of garbage printed out to the log or the standard out or wherever this message is going. But thankfully, modern compilers know how printf works, and they understand that printf has a particular syntax, and they can tell you when you've made a mistake. So this really was a compiler error, I'm glad to say. Well, provided you turn on all the warnings and turn them into errors, for example, which I recommend you do if you're working on your own project. If you're writing libraries for someone else, have it as an option. So here we were really, really lucky that GCC was able to find this was an issue. And like everyone has been saying in the chat, the simple fix for this is that we just turn p-area name to p-area name.cster. And of course, there'd be maybe a half dozen places in the code base where this was happening. Luckily, most of them were in like printf style bits of code like this. And again, there's any amount of awful things that's wrong with char buff max string length, right? We'll get to that in a bit. But what about things like this? So we had written routines already that were printf-like to make our life easier. So we had this buffer object here, which is essentially like a standard string type thing. It's like a buffer we're sort of accumulating text into before we then send it off to the player. And it took a text format string, and it took a ... too, and it kind of did the formatting the same way as printf did behind the scenes. We don't get any protection for this, unfortunately. But wait, we can use the same trick that the compiler uses, at least on GCC and Clang and ICC. They all support this extension. So this is a language extension, a GNU one at that says, hey, this function behaves like printf. And you can teach it that the second parameter is the format string, and then the third parameter onwards is where the ... comes in. And it will give you the same errors for your own functions as you would get for the standard functions, which is a great thing to do. And there's a number of other things. So it understands scanf and things like that too. So once I'd realized that I could do this, I was able to find the half dozen or so places where we were doing this, annotate those accordingly, and make sure I caught all the errors everywhere. So that's pretty cool. So then we move on to the second part of this, which is just run it and see what happens driven development, which is kind of what we've been doing all along, right? The whole way through I've been saying, and I just ran it and played around a bit and killed some monsters and stuff. And that's what we're going to do here. We are very, very fortunate though, because we're going to be saved by, someone's just asked a question. Did you add the GNU format prior to replacing with format lib? I did actually add all of those beforehand because, it was a long time coming. There are still, I think only recently did I get rid of the last printf. There were like thousands and thousands of them in the code base, as you can probably imagine. Pretty much every single piece of text that came out was a formatted string, and there's a lot of them. So this is just run it and see what happens driven development. Thankfully, we have the sanitizers also as our second stop. So the compilers and their warnings and errors are awesome and have caught out a lot of stuff. Now we can run it and we get runtime errors for things that we have made mistakes with. And this is one of those things. So this is telling me that somehow I've leaked 10 bytes at this particular spot in the code base. And if I go and look at where that line is, line 394 of Xenia source, whatever, I can see that it's something that looks a little bit like this. Obviously, I'm trying to make this look straightforward for slide purposes. So this is in the loading code. So I've given just enough of the area data for you to be able to see or remind what that looks like. And while it's parsing an area, there are some horrible C formatting type things, which I haven't replaced yet, that are read a single string. And in mud speak, a string is something which is terminated by a tilde, just because that's the way that the format works. So it just reads as many bytes until it's got a tilde, puts it into a horrible static buffer, and then returns a pointer to it. Blech. Right, that will go eventually, but bear with us. And then what it was doing, of course, is it had to take a copy, a duplicate of that string, because that buffer would go away when the next thing was parsed. And so the original code was area name is equal to string duplicate, take a copy of the string I just read from the file. And of course, we're now changing this from being a char star where it was owned by the char star into a standard string where the standard string itself will take a copy and manage the memory itself, which means that whatever's on the right-hand side of that equals is just allowed to disappear off. And that's where we're leaking. So that duplicated string is not being cleaned up by anybody. Now, the astute among you are probably wondering, if this is the case, who was clearing up the name before in the old style code? And the answer is nobody was, but for very complicated reasons involving custom memory managers and replacing malloc and free and things, it wasn't actually being tagged as a leak in the old code. We can go into that in the drinks afterwards if people are interested. But this is luckily a very simple fix. I just get rid of the strudup, right? We can just take that static buffer that's valid only until basically the next call to fread string and assign from it, knowing that now we're taking a copy and it's going to be managed by our standard string name. And that was the last thing we had to do to get our single name field from being a char star to a standard string. And so just sort of taking a step back, we have essentially an entirely C code base with one little bit of C++ buried in the middle of it. In other languages, when I've had to do this kind of stuff, I've often had to like partition into a separate library and have thunks between the versions or other stuff like that. But here we can actually make a single field C++ and leave everything else essentially C. And that's a great, powerful thing. So obviously now we've got one of these strings, we can change the other ones. And there's nothing new that's going to happen there. We're going to find the similar printf type things. We're going to find similar load type stuff and string duplication. So I'm not going to go on about that too much. So the next thing I want to do is get rid of that next pointer. I'm going to turn these things into an STL container instead of being a custom handwritten linked list. Now, for reasons that now I think about it, now I'm doing this presentation, don't make that much sense, I decided to not use the obvious choice, which would be a standard forward list, which would at least be the same as what we had before, a singly linked forward pointing list. I decided to put them in a vector because, most of the time a vector is the right thing to do. So I literally got rid of the next pointer and then I kept a global and I made it a vector of area datas. And this is the first time that I put one of those to-dos down saying, I should really stop this from being a global because I don't want globals in my code. It's hard to test. So Incidentally, this number here is my little thing. I always, if I put a to do in my code, I will link it to an issue or a bug. This could be a Jira ticket, or it could be a GitHub issue, something like that, to give me some two-way between the code and sort of the management generally of all of the things that are yet to be cleaned up. Of course, this is a hobby project of mine, but I still like to do everything the way I do things professionally in my hobby time. So obviously, if I'm turning something into a vector that previously was a malloc and a linked list sort of stuff, I need to make some changes to the code. So this is what the code looks like after I made the changes. So I construct an area data that's just empty. I call some external parse area free function that takes an area pointer and the FP, and it just parses the area from the file pointer into that area. And then I'm going to add it to the global list of areas. And then there was some existing code that needed to know what the current area was, because when I load up rooms and mobs and things like that, they need to refer back to that area to say, hey, I came from this area. And so, you know, that's what happens in this second bit here. A bit later on, the code is making a room, and you can imagine there's some kind of room data structure. And somewhere in here, it says that, hey, this room's current area is whatever the current area is. And so, you know, that's what I replaced like with like right here. And then I ran it. And hallelujah, once again, for the address sanitizer this time. So last time it was the leak sanitizer, now it was the address sanitizer. And it's saving us from ourselves again here, or saving me from myself, because I was being far too quick. I was making far too many changes at once in this particular instance, because I'm now accessing apparently heap that has been freed. This is saying this memory that you're accessing here was allocated or freed here, but previously allocated over here. And if I had room to put the whole call stack in, you could see it was to do with the vector we just introduced. So I'm sure some of you are already knowing exactly what's happened here. If we look at the code itself, we can see that this is some bit of code later on. The rooms, like I said before, have a pointer into the area. And somewhere in the room logic, it's saying, hey, I'm going to reach back to the area I came from and do something with it. But as you know, if you're adding things to a vector, as we're loading more areas into the game while we're booting up, the areas that are inside that vector are going to move around in memory. We can't guarantee the pointers, that the memory addresses of those things are going to stay the same. In fact, they're almost certainly going to change. So what we need is pointer stability. What we need is address stability of those objects. One way to achieve address stability would be to go back to using a list, a standard list or a standard forward list, in which case we know that the elements of the list don't move around as things are added and removed from the list, and that would give us the stability we need. But because I wanted to get rid, or I eventually want to get rid of the need for that pointer stability, I stuck with a vector. And instead of having a vector of area datas, I decided to go for a vector of unique pointers to area datas. And I added myself another to do to say, hey, later on, I really want to get rid of the fact that these things need to point back to me, or guarantee in other ways that the objects aren't going to move around once I've loaded them up. There are other tricks for this, but I just want to sort of show the process that I have where I'm trying not to punish myself too much for doing this. And people are asking if I write myself invoices for my time in the chat, which no. So anyway, that gets us working again. We now have got rid of the pointer in the object, and there's a few other bits and pieces inside that area data. And now I thought was the time to turn it into a class instead of a struct, because at the moment, really what it is a struct with a bit of extra behavior on the side. And so turning a struct into a class, as you probably know, struct and class are essentially the same thing. The only thing is that a class defaults to being private and a struct defaults to being public. And in the spirit of my minimal changes, I'm going to, first of all, turn struct into class and then just make everything public immediately again. I mean, that's actually a change I can make, and I can be pretty sure it's going to have no side effects. And I can run my code, I can check that it's working, and that's great. And then one at a time, I'm going to move each of the individual members into the private section from the public section and deal with the consequences. So let me show you how that's going to go. So obviously, there's my struct. First thing that's going to happen is it's going to be class area data, and I'm going to make everything public. That just worked, right? There was no real surprise there. Next, I'm going to move the name into a private member, and I'm going to make an accessor. Now, once again, all of the same places I just changed, which had to be changed because of the CSTR or the lack of struct, they're mostly going to fall over again, because instead of name being a standard string, name is now a function that returns a ref to a standard string. So I have to add some parens in a couple of places, but the compiler helps me out here. We're back to sed here. We're back to compiler error driven development, and then everything's working. But of course, I also need to set the name in the first place. One thing I could have done would be to just make an accessor to mutate the name, have like set name, a little a function like that. But I noticed that nobody other than loading the area set the name. And I kind of want to keep that. So this is an opportunity for me to hide and encapsulate that name away and make it so that the only thing that ever sets the name is the thing that parses it out of the file in the first place. So in order to do that, I moved the parse method out from being a free function into being my first proper member function. And that was a relatively small change. You can probably imagine how simple that was too. I left everything else the same though. So it's still reading into area name. It's still reading into file name. It's just that this function can, of course, initialize this name underscore private member, which is great. I could run and I could test. Everything was groovy. And then from then onwards, it was a case of just doing the next one and then the next one and then so on and so forth. So now I've got an actual class that has accessors for the things that are read-only, and the only time it's being mutated is during the load. Now, there are still some public members that are outside of there. So someone's just asked if I wanted a constructor taking a file star. I decided against that, and you'll see where I ended up with that, just because anything that throws, I kind of personally prefer it not to be in a constructor. It seems surprising to me, although I'm totally down with it. But we'll see what the final step was there. But so now I'm going to continue moving things out. We've already moved parse area into a member function called parse. I'm going to move the rest of the functionality, and I'm going to show you like how it all ended up rather than sort of talking you through each one individually. You can kind of see the stages that you go through. Finally, as well, by the end of this, I had a nice idea of what this area was doing in the whole code base. I had controlled who had what responsibility and where the sort of side effects were happening. And that meant I could write tests with a lot of confidence that I was covering the surface area of that particular object. And then actually, after I'd written the test, I renamed half of the fields and accessors because they have terrible names in the original code. Like, I don't know if you saw, there was something called area, and there's something called name, and there's something called area name. And they were very confusing to me while I was even writing the code. So this is what the final, this is a flavor of what the final area class looks like. And I also renamed it from area data into area. It's no longer the data associated with an area. It is actually the area itself. And so we've got like a description that used to be what name was, or maybe it was area name. I forget which way around it was. We've got a short name, which was the other one of those two names. I have a default private constructor because I'm not allowing anyone to construct these other than the static now area, parse function, which is going to return you a parsed out area or throw an exception if it failed. Like was said in the chat, you could reasonably have an area constructor that takes a file star. For whatever reason, I decided not to here. And I kind of like the idea of a named function that's very clear about what it's doing when you're actually like parsing an area from a file rather than sort of constructing an area from a file. I don't know. Again, haven't thought that one through as much as I perhaps should have done. I've started to extract some of the functions, the functionality that was scattered around the code base to like add and decrement some of the counters that are inside this area. So although I didn't talk about it, there's a counter of how many players are currently in the area. There is a little flag that sort of knows whether or not people have entered the area since it was last reset. And the logic for that was in about 5 different places. I was able to extract some nice named functions that actually tell you what's going on and why it's happening, which was nice. So I gave some names to behavior. The update method is like the one true tick function that says everything inside this area needs to be updated. If there are rooms that need to be like doors need to be relocked after a certain amount of time because no one's been in there, or dead monsters need to be respawned. That's what this update function did. And there's a lot of nice things that you can do once you started isolating stuff, which I'm sure you're all aware of. And then obviously, the accessors, I started getting really funky with, no discard and autoing all the places and things like that. And, obviously it's called short name now, and that makes more sense than name or area name. The short name is literally the thing that just says, like Imladris, and the description is like Imladris, a place where you can go and blah, 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 that kind of thing. So it makes sense now. There are names that make sense to me, at least. And I talked about testing. Finally, I can actually write some tests. Now, that's not to say, in honesty, that I couldn't have written tests before. I chose not to, mainly because the code was so ugly, I just couldn't bring myself to, which is a bit of a bad excuse. But let me just sort of show you what a test looks like. It's pretty straightforward. I can make a memory-based file. So this was something that I learned fairly recently, is that you can make a file star, like a C-style file star, that points at some memory pretty straightforwardly. And I've wrapped it in a class called test mem file here, but it's pretty straightforward. There's just some POSIX commands that let you do it. So that allows me to construct a test file that's just inside the test. And this is what an area file looks like. Here's those tildes that we were talking about where it's tildes delimited. There's the short name. This is the description. And then there's some numbers here. And we just check that everything parses like you might imagine. We parse the file and then we write some tests and checks there. And that's all we need to do there. That's pretty straightforward. And obviously then you can test that things are broken, things handle the fact that numbers aren't numbers, and throw exceptions and all that kind of good stuff. And that's kind of nice now. We've got a tested class that used to be a very, very manky C structure. So that is kind of the flavor of how things are going to move on in this. That testing framework is Catch 2, which is it was originally Phil Nash's testing system, and now I forgot who took it on, and I should know. No, I can't remember. Someone will put it in the chat. But I recommend it. This Google test is great too. Don't get me wrong. I've just gotten used to how Catch works. It allows you to build up test cases in a kind of hierarchical way without writing fixtures all over the place. So I said that the MUD is basically a string processor, and we've seen a little bit of parsing code, but not much more of that. So let's take a look at some of the string manipulation that's going on inside. Martin Horonowski, thank you, Ben. Yeah, I do like Catch 2 too. So there's a lot of string manipulation going on. We've got functions to capitalize the first letter and lowercase everything else, uppercase the whole thing, lowercase the whole thing, trim white space on either sides, case insensitive matching of strings so that people have got shout caps on it. We can still tell that they're typing go north. Prefixes and suffixes, tokenizing, parsing, all these things. I'm going to look at a couple of those functions as they were written in the C code, and then I'm going to show you how they can be written in C++ in various different ways, which is kind of a slightly different style from the rest of the talk. And this is now me kind of breaking the fourth wall here. I realized afterwards that I've kind of moved out of like the iterative process of turning an old piece of code into new code into just like, hey, here's some cool stuff you can do, and here's the equivalent horrible old C code. So if that doesn't fit in, if you don't think that's great, let me know at the end. So we're going to look at a string manipulation code to capitalize the first letter and lowercase the remaining letters of a given string. And how wrong is this? Let me count the ways. The first thing we're going to notice is that it returns a mutable char star, which is a horrible anachronism. It launders the fact that it was passed a constant char star, and it returns a mutable char star. Worst of all, that's another static buffer somewhere that's being used. So, whoever calls this function is getting a mutable pointer, all right, but it's like shared with whoever else calls this function next. So you better use it and forget about it. It's all the horrible things you might imagine about this kind of era of code. It's just stepping through every single character, lowercasing them. This lower is a macro, as you can imagine, doing exactly the thing you think the macro is doing. It gets to the end, it writes the null byte in, and then it unconditionally just uppercases the 0th byte of the string, which is interesting and has a side effect that you'll see in a second. Now, unlike the other bit of code, I was able to easily write a test for this before I started. So I wrote this test as a starting point. So this is just me checking the capitalized function. And we're definitely going to be changing that return value. If you remember, it was returning a mutable char star. So I've just used the trick of making sure the right-hand side is always a string. So this S suffix here, if you're unaware of it, is one of the standard literals you can use. And now this turns this into a standard string on the right-hand side, which means that as long as this thing on the left-hand side can be compared with the standard string, it's going to do something sensible. So I didn't have to monkey around with strcmp and all those horrible things to check that things were right. So here I'm saying, does the empty string work, and so on. And this sort of comes to my sort of methodology. And I say my methodology, it's someone else's methodology. It's a methodology known as zombies, which I think is a great an acronym for the first few letters at least. So what zombies stands for is 0, 1, many, boundaries, interfaces, exceptional, and then scenarios. And I didn't get any scenarios in this because it turns out that capitalize doesn't need to have scenarios. But it kind of makes you think about the things that are important to test. And so it's always worth thinking about this at the back of your head. So 0, for anything that takes a sequence, try it with an empty sequence is what 0 means. For anything that takes a sequence, try it with a single element and then try it with many elements. That's what the 1 and the many are. Boundaries are like take it up to the extent of the function. You know, if you have a function that takes int max or, you know, int min, then make sure you pass in int max and int min as well, just to make sure that it works with those extreme cases. Check all of the parts of the interface. Well, as it happens, there isn't really anything here. I just put this here because I can't remember what the I stands for unless it's in a comment. And exceptional situations, so things that are unusual. Now, there aren't any actual exceptions in this particular code, but I chose to mean that as being like, you know, hey, have a mixture of uppercase and lowercase. That's kind of unusual. You wouldn't expect to see that. But really, again, this is just to remind me that the E stands for exceptional. And yes, this code has no internationalization at all, and it's all UTF, not even UTF, it's all ASCII. And in fact, it uses ANSI control codes. So there are any number of things that are very specific to this particular style of text and the expectation of the terminal on the other end. And I'm just going to make sure, oh yeah, that's all good. Everything's good on there. Okay. So this was my first attempt at changing the code from the horrible C into lovely C++. And it didn't turn out that great, I'll be honest with you. So let's just take it apart and have a look. The first thing you'll note is, that I haven't highlighted the lines I thought I was highlighting. So I'll use the mouse, is that I'm returning a standard string now. So this would be a breaking API change. And as well as writing this as standard string capitalize, I'd have to edit a lot of the code base just to deal with the fact that a lot of stuff would now need a .c stir and things like that. Luckily, nothing was taking advantage of the fact it was returning a mutable char star. So we're lucky on that front. So I'm returning a standard string now. So now we're no more worries about who owns what, or, you know, calling the function twice and getting overwriting the previous caller's strings. And this is pretty much a transliteration of what happened before. In the C code, we've got a result. I resize it to be the right size. I do a to lower on all of the values in the whole string, and then I just uppercase the 0th one. But this is exactly where the Z of zombie is going to save me, because that is a bug right there. As you can imagine, if you've got an empty string, when it was a char array, you can uppercase the null byte in a char array all day and no one cares. But when it's a standard string, you should not be reaching into the 0th element and doing anything with it. So that was a bug that was caught by the tests. So then I thought to myself, it's pretty nasty. Well, first of all, I can deal with the empty case and just get rid of it and say, hey, if you pass me an empty string, you get an empty string back. That's pretty nasty. It's pretty straightforward, but it's a bit of a special case. I don't like dealing with special cases. I also didn't like the fact that I was resizing the output, and I felt like, you know, this no raw loops thing was probably worth looking into. And so I thought, well, what does it look like if I use standard transform? So standard transform takes an input iterator pair, like start and end, or begin and end of where it's going to be transforming. It takes a destination to write where all the transforms results are going to go. And in this instance, I'm using a back inserter, which means that every time we write to it, we're pushing to the end of whatever we've given it. So in this instance, it's pushing to the end of the result string. And then I'm going to give it a little function that's going to be run on every single one of the input items. And so in this instance, the input items will be characters, and we're going to be returning a character. And you might think that you could just put stood to lower in here, but unfortunately, stood to lower takes an int and returns an int. It doesn't deal with chars at all for all the internationalization type things that Ben was talking about. And so that doesn't work. But for all the strings that I care, I'm essentially this is just a cast to a char and back out again from a char. But it's just an unfortunate thing that I have to use a little lambda there. And then I uppercase the last one, the first one. Now I know because it's not empty, so I can do this, and I return it. So that's still very unrewarding. All the tests pass, but it's not very lovely. So let's bring in some new C++ things. So I want to bring in string view, because across the board in my code base, I'm going to be passing a lot of char stars and stood strings and things, and I'm mixing and matching a lot while I'm converting the code from old style to new style. It would be nice to have a lingua franca where I can have either a char star or a standard string, or indeed a string view actually. And string view is a great way of being an input parameter for basically anything string-like. So I want to use that. And I want to use ranges because I know they're coming in C++20. Now, this talk doesn't get into the ranges in C++20, and those who are knowledgeable will know that the things that I'm doing can't actually be done in C++20 yet, maybe C++23. So this is ranges v3 in C++17. So this is one way you could write capitalize. So first of all, I'm returning an auto because I know what the type is. I'm spelling it out down here. I'm taking a string view, which is great. Now, if someone calls me with a char star or a standard string, it will just work and the right thing will happen. And if they call me with a string view, that's also great. The thing about a string view is it is implicitly a range. And let's talk about what a range is. So conceptually, a range is a kind of tuple of a begin and an end. And instead of having to always pass the begin and end, now we kind of bundle them up into one thing and call it a range. There is some special stuff about the end also can be a sentinel value, but for the purposes of this, we don't need to worry too much about that. The other thing that's cool about ranges is that you can put views and transforms onto a range. And then as you read through that range, those transformations are applied step by step, which allows us to write this kind of code. So maybe an example will be the best way to show what I mean here. So we're going to take the text, which is implicitly a range. We're going to pipe it through this enumerate function. And what enumerate is going to do is it's going to take a range and output a new range where each element is the ordinal value in the sequence, like 0, then 1, then 2, then 3, and then the element from the sequence. So we'll get 0 in the first character, 1 in the second character, 2 in the third character, and so on. That requires a lot of thought because, of course, there's one difference between those two. And the reason we're going to do that is because we're going to transform it, and we're going to use whether it's the first character to select to upper of the second of the character or to lower of the character. And that allows me to do a single pass across the whole thing, uppercasing the first character and lowercasing everything else. Of course, at the moment, we still just have a range, which is not what we wanted. And this is one of those C++20 missing features, unfortunately. What we can do is we can pipe it into something which turns that range into an object type. You can collect it into a vector or a similar container. And in this instance, I'm collecting it into a standard string. So we take that input range, we shove it through this transformation pipeline, and it comes out the end as a standard string. Anyone who uses Unix will recognize like the pipe syntax to take the output of one program and move it into the next. In this instance, we're doing it with ranges. It's quite cool. There are people talking about various things, which I'll be really interested to talk at the end because this is new to me and I don't know if I'm doing it right. So I'd be very interested to hear if there are better ways of doing this. But that was my first attempt at using ranges. And I'll be honest with you, it's slightly less code than this previous bit of code. And I didn't have to special case the zeroth, the empty string version. So I think it's a win, but it's a weak win. Oh, to go through all of this. So this was the final thing that I came out with, which I think is a little bit nicer. And so in this instance, what I'm saying is that the result is the concatenation of two ranges. The first range is take the first character and transform it to upper. And then the second range is drop the first character and transform everything in that range to lowercase. And then I turn it all into a string at the end. So that's fairly concise. Again, I don't know if there's a better way of phrasing this. I'm hoping that somebody smart in the chat will tell me that there's a really succinct and cool way of doing this. I believe that C++20 ranges does have take and drop, but it does not have concat. So we still can't do this and we still don't have to. So I'm kind of teasing you with things that we might be able to have, but unfortunately we don't have yet. Anyway, that's capitalize. And and I had some highlights for that. But the real thing, yes, exactly, Leslie. Yeah, it's better because you don't have to check if it's the first character. It feels a little bit nicer. So at this point, I was sort of still somewhat on the fence. You know, I'm very much an imperative programmer. I do like to write my loops, but I'm trying to be open-minded to new ways of writing code. And this is a great opportunity for me to try out new ways while I'm porting this ancient code. But this is what really sold me. So I needed to write a case-insensitive str. That is, I want to see if one string is inside another larger string case-insensitively. Now in POSIX, sorry, in GNU extensions for POSIX, you have str case str. but that only works with 0 terminated strings. And once you start accepting a string view, you no longer have a null terminator on the end of your string. So you can no longer guarantee that there's going to be a null terminator one off the end of your string. So you have to deal with things that understand that these are ranges of bytes. And str doesn't work. So let me show you how the C code implemented the case insensitive is one string in another string. And it's this, I had to edit it to even get it slightly fitting on the slide. And in fact, it doesn't fit on the slide because there's this other huge function somewhere else that is a case insensitive, has this got a prefix. So this is so awful. I'm not even going to go through it because it's just, yeah, it's awful. There's some vestiges of some like things that used to be optimizations where it would special case the first character and scan through looking for the first character. And it's just horrid. So cutting to the chase, this is how it looks in rangeland. And I love this. This is the best. So we have the needle and the haystack. The needle is the small string that we're looking for in the big string. I create a range that is a transformed version of the needle where it's transformed to lowercase, and a haystack that's been transformed to lowercase. And then I say, hey, ranges, is this range inside this other range? And we're done. And that was just lovely to write. Now, I haven't mentioned Compiler Explorer the whole way through this talk, and nor will I bring it up because the obvious question here is like, but how efficient is this? Well, first of all, I don't care for this particular project because, you know, I haven't got a 200 megahertz machine that I'm sharing with 100 other people. I've got some behemoth 4 gigahertz thing that I sat under my desk here. So performance is not that important to me. But the real answer is the code output is pretty terrible, actually. I hope that compilers and the range folks will work on it and we can get better results. But at the moment, it's kind of somewhat catastrophic. So I'm sort of not showing it to you out of embarrassment. All right, we've got the next session is on string formatting, which is probably the biggest set of changes that had to be done to sort of really capitalize on those other changes that were made. And I think there were some questions earlier about, you know, should I have done the string formatting first? I think I probably should have done, but you know, you learn as you go. So a lot of those .c strs that you saw from before ended up being taken out eventually with the solution that I'm about to show. So obviously the code is completely full of things. You've already seen a few of these as we saw earlier when we were talking about the magic GNU printf annotation. But like, yeah, first of all, anything that's taking user code typed in off the internet and putting it into a fixed length buffer is terrifying, right? So, this isn't user code in this instance, but the code is full of this kind of stuff here. And I'm sure you've seen this in your code bases that you've been through. So the obvious thing to fix this is to make it SN printf, right? I mean, it's slightly better, but ultimately it hasn't really fixed the underlying problem, which is that there is this hard cap on how many bytes I can fit into that string. I can do this. This is a bit like the other thing that I showed you with the buffer formatting, where I can at least hide the fact that there are all these little buffs that are max string length everywhere by placing it in essentially the implementation of char send to, and then I've at least only got one place that I need to edit if I need to fiddle around with the size of that buffer or I need to do other checks on it. And then effectively I've got my ... thing going on again. So obviously if I'm doing this, I should put in my GNU format annotation so that I get the power of the compiler helping me out if I've made a mistake somewhere, but this is still not the best solution. The real solution is to use the new format library, which is coming in also in C++20 as standard format. Again, I'm using a couple of things here that I don't believe made it into the standard, but more of this library is available than the ranges library, in my understanding. So here, instead of it being a vendor-specific compiler trick to annotate the fact that the function takes this kind of mystical parameters, here we're just using good old-fashioned variadic templates to pass through the arguments to a library that understands the format and can format the arguments based on their actual type and not the type that you told it was in the format string. So this is a lot better already. I have to use this sort of Python style syntax of the little open and close curly braces here to put my placeholders in. So there was a lot of changes that involved that. It does support all of the usual formatting of, you know, spaces and left padding, right padding, putting trailing zeros in and all that kind of stuff. But here it means that I get all the benefits of these things being formatted, knowing what type the object is. So I didn't have to say this is a %d. That's a number, so it'll be printed like a number. likewise all of the other things here. If it was a standard string, it would just work. I don't need to pass a .c stir in anymore. In fact, I think I just said, I had to go back through the code base and delete half a dozen .c stirrers off of things that were no longer necessary. It works with string views, so that if I return like a temporary view into another string, if I'm like doing white space trimming off the left and right, and I return a string view of the middle part, I can still print that out, and I don't have to go through an intermediate object like I would have done before. So it's just all out a win. And so, you know, sorry, forgot about this slide. We are now in the situation where we can do some clever things with lists of things. So it works well with ranges. This is a bit of code that says, when you've leveled up and you go and speak to your guild master, and you say, hey, I'd like to train. He says, hey, you can train these things. And there is the list of parameters, attributes that you can still train, like your strength and dexterity, if you haven't already reached the maximum cap for that. And there are some statistics that you can always train, your health points and your mana. Now you can imagine what this code looked like when it was back in char max string world. It was tons of strucats and a loop, and that's always a pain. And, you know, anytime you have to deal with the fact that there may or may not be a separator between things, it's painful. We've all written that code. It's like bool, is this the first equals true? And then if is the first, then put a comma, else not put a comma, that kind of stuff. Well, we don't have to do that anymore. We can treat the list as a single entity and use format join to say, I would like you to take the string and I want you to join this range of things with this value. And in this instance, I just wanted this to be a space, they're space separated. And then this range itself is the concatenation of all of the statistics that are available, filtered by this function, which says, you know, is it already at its maximum or not? And then transformed, oh, I forgot to highlight it, transformed from the attribute to the name of the attribute. And the concatenation of that and the list of things that are always trainable. So this may not be as readable as the sort of stage by stage thing that's printing out and sprintfing and whatever, but I quite like this. I think once you know what it's doing, you could, and once you understand how ranges work and you can kind of read them, then that's pretty readable to me. I'll be interested to know what folks will we'll see. And Ben's asked the question, did you discover any previous unnoticed conversions now the format doesn't convert? No, I didn't actually in this, luckily. I haven't hit anything funny that the format hasn't handled for me in this instance. And it's only, I haven't taken advantage of this yet, but there's a world in which we could say, you know, like print out a character, as in like a player character, and have the name turn up, that kind of thing. But I haven't gone down that route for a variety of reasons. But the door is open. You can add your own custom formatters, just like you can with IO streams. So string formatting, this is, you know, the Galaxy Brain meme thing. You know, sprintf is one thing. If snprintf is the next one, then, you know, using the GNU printf extensions is the, and I know to need to come up with names for this. This is terrible. Sorry, everyone. But obviously the Galaxy Brain ultimately is to just use format. And if you want to do any kind of printing with format, you've got format : print. You've got format : yeah, format. That's it. Sorry. We're now reaching the part of the talk where I said I would be starting to run on more vapors in terms of the slides. So just some directionality comments would be appreciated towards the end about which things you think I should drop, which things maybe I should extend on. I'm aware that we're at now, what, 8:15? 20 past 8. Okay, so time-wise, I want to sort of wrap up in the next 10 or so. So if Jason's awake still. There was some other cool things you can do with the ranges. One thing that I do is that there's an awful lot of iteration over subsets of the other people in the mud. So when you yell, when the player yells, then we send to them, you yell whatever they said they were yelling. And then for everyone else who's in the same area, Jason's still here. For everyone else who's in the same area, we want to say, Bob yells hello or whatever. And so that there was previously tons and tons of bespoke linked list walking, as you might imagine, followed by all of the if statements in the world to say like, well, if it's this, but not that, and this and not that. And so you've got like a half dozen lines of if statements in the middle of a nested loop. Now we can just use ranges for each and say, get me all of the descriptors. And the descriptors in this instance is the list of all connected TCP sessions, except for the current one. Filter it to be all the ones that are in the same area as this. And this descriptor filter : same area is something I wrote. It's just a bunch of static range filter functions. and then turn it, this is more of a transform than a filter, turn it from the descriptor, like the TCP connection, into the character that's associated with that TCP connection. The reason we have to do that is because when you're running quests and things like that, the player that you logged in, if you are like a DM, is not necessarily the character that you're playing in the game. There's all these complicated things, so bear with me on that. But anyway, this just gets all of the other characters that are connected to a TCP connection that are in the same area as you, and then I'm going to say run this bit of code, and that's kind of a neat way of being able to like filter down very succinctly. And obviously, this has been formatted for slide code. It fits on a few fewer lines in the real code. Placeholder. I would like to talk about some of the more strong types we introduced, and there were a ton of bit fields that we had throughout the code base, and that were just uint64, sorry, not even uint64s, we didn't have uint64 back then, uint32ts and things, and they now can become strong type things, but I haven't got slides for it because I'm low on time already. And then there was just one sort of technique that I want to talk about, which fits more in with the original topic of taking old code and iteratively adapting it to fit. And in this instance, what I want to talk about is how our command parsing works before, and how I was able to come up with a way to be able to take what would have been otherwise a huge change and make it into lots of smaller changes. So the old system that we have for parsing relied on every single function in the MUD being a function that looked like this. It took a character as the first argument, and then ironically, it took a character pointer as the second argument, right? Like, so a char. Yeah, no, we had no size problems actually in this instance. Someone was asking if there are any 32-bit to 64-bit problems. There were none, amazingly. So this is the character who's logged in, and this is what they just typed in, right? Char star being the problem here. And then every single function like yell or say or cast or north or south or anything like that had to do its own argument parsing. So you think of it as the worst, CLI tool ever written. And I wanted to change that. But of course, we've got hundreds and hundreds, about 1,000 of these functions to handle with every single command that the user could ever type in. The old code looked like this. It was given a character and the whole thing they typed in. It sort of split off the first command, looked it up in a sort of map of sorts, which would return one of these free functions. And if it didn't have it, it said, I don't know what you said. Otherwise, it just invoked that function and said, okay, good luck. You parse the rest of it yourself. I'm done with you. This obviously is not great. I wanted to combine and consolidate all of the parsing into one thing. Here's an example. Oh, that should have const in front of it. Sorry. There's just literally hundreds of functions that look like this. Do save, do say, do score, do set. Everything that you can type in the MUD was another one of these commands. And what I want to be able to do is I want to take one of those and say, no, you don't take a const char star args. You take something else, maybe an argument parser or some kind of wrapper around something which is going to give me functionality and has state in it, as opposed to this horrible thing where we're copying bytes around. So this is what I want it to look like. I want to be able to say, hey, this function takes no arguments, so I don't need to pass the arguments. It doesn't matter what the user puts in. I want to say this function takes like an argument parser object, which I can ask questions of. And then like, this is another function that I haven't yet updated. And I've got like literally 997 of these. And I want to be able to incrementally do one line at a time, one function at a time. But at the moment, I can't do that because I've got like this one size fits all solution. So, that's what an arg parser looks like. Darn it. Sorry, I forgot that I put that slide in. So what I decided to do was rephrase everything. So this is, what I've lost track of it. There's a do func. Yes, I'm sorry. Yeah, the way that the commands are populated was effectively, for every function, there was a little bit of code that says, this is the string and this is the function, this is the string, this is the function, hundreds of those. And what I want to be able to do is interpose something so that I can select the right function to call depending on what the arguments of the do func that I'm calling. And I realize that now sorry, my kids are being very loud in the background. So I've introduced a standard function instead of a raw function, which allows me to stuff like a lambda into that bag. And what that allows me to do is for all the functions that just want to take a char star and an arg parser, I can just, that's the sort of the default. But if there's something which takes one of the old style functions where we have just a char star and a const char star, I can make up a little lambda that does the conversion there and then between the old style and the new style. And that means that I can list all of the old commands. I didn't have to change any of the old commands. They would automatically find this overload. Their command would be adapted to fit the new style, and I didn't have to make a load of changes. So yeah, as you can tell, this is not the most thought out part of the whole talk. So again, feedback, welcome. Okay. Oh, and I've got highlights. Some other things, standard arrays everywhere. That might be a more interesting one to elaborate on, using ranges to fill arrays of things instead of having all this kind of like less than max or whatever. But again, thoughts welcomed. Let me talk about some of my regrets. So that's the end of all the sort of examples of things that I changed along the way. There are definitely some things I'd like to have done before I got to the talking about it. And that would have been using fuzzing, right? Fuzzing's the new hotness for testing things that interact with, user supplied input, and a MUD is nothing but a new input. Sorry, user input. I read something that was going to say. I left all of the globals as globals. I have started moving them towards using singletons in a couple of choice places, and then everything else is a member function of the singleton. And I try to pass everything as a reference to the object that's in the singleton instead of like a singleton class. My hope there is that eventually I can wrap everything in a big like MUD object that brings everything together, and then I can get rid of the singletons. But I haven't got far enough down that route to confidently say that that's going to work. And obviously I'd love to have got this to C++20 instead of using a range library that is from non-standard, even though Conan makes that relatively easy to do. So it would have been cool to test out all of these things, but I didn't have time. Let's get to the conclusion then. So obviously, I've been talking a lot about some ancient code for a game that no one will care about, that's text-based and was anachronistic even when I was working on it. So what do we really learn as C++ developers in our day jobs moving forward? Well, first of all, the things that helped us along the way, the things that have improved in the last 25 years. So compiler warnings have saved us a number of times. The sanitizers are worth their weight in gold. They are just brilliant, right? You can't, it's impossible for me to imagine going back to a world where I don't by default build my code in debug with all the sanitizers turned on and use that as part of my testing process. We know that compiler error-driven development and test-driven development-ish have helped us make some changes along the way. I mean, obviously, there's nothing new under the sun. We've always been doing compiler error-driven development. That's kind of how we code. Backwards compatibility helped us here, though, right? If I had to have spent too much time other than like renaming class to being class or whatever, I would have been basically rewriting or porting rather than just slowly and incrementally adapting a 25-year-old code base. But what does that really mean? I mean, what it means is that you can do that. And I'm sure some of you have got code bases that are decades old. I think some folks were saying that they were working on pre-C98 code bases. And that's amazing, right? The fact that you can be, I mean, maybe it's terrible that you still have code that's old, but it's allowed a continuity from the 90s through to now and before, right? There are times before. That can be useful. Often we think of it as very legacy, but in our now job, we take advantage of this all the time. We perhaps don't think about it as much as we ought to. Like next time we get a revision in C++, like C++20 comes out, we don't think twice, or certainly I don't think twice about just turning the flag on as soon as it's available in the compiler. And I am 99.999% sure that my existing code will continue to work exactly as it is right now without any fear. And that's because C++ has backwards compatibility. Now, normally we think about backwards compatibility as like a backwards facing thing of like old stuff. But what it means is that our current code is old tomorrow, right? And we can rely on C++'s ability to remain backwards compatible to keep our code base moving forward without having to have like a big bang style every few years when the new revision drops. You can incrementally update. And in fact, Compiler Explorer itself was born out of that transition. Compiler Explorer was born out of a need to show my employer at the time that we could turn on C++ 11 flags, or C++ OX as it was then, and our code didn't change, right? That was a guarantee that we got from pretty much everything. It was like, just turning this on and everything looks the same output happens. I can turn the flag on and off, no difference. I can write a range for, and if anything, it's slightly better than the code it was before. And that's incremental. I don't have to apply it to the whole code base and then have everything change under my feet. I could turn on the flag and then I could pick one range for at a time. And that's an amazingly powerful thing to be able to do. And this is something I didn't think about until I gave this presentation at work. What we also have to think about here is that the code you're working on now might still be running in 10 years' time. And if you're developing something that's significantly important, or you've invested a lot of time and resources into it, knowing that your code will continue to work decades into the future is a pretty powerful thing to be able to rely on. Right. The code that I wrote 25 years ago was just a bit of a joke that we got working today. But if my code is running in 25 years time, that's pretty impressive. Right. And not every language you can say that. I mean, like if you think about how Python has been sort of retired, Python 2 is retired. That's kind of a problem for people that are stuck on Python 2. We don't have that problem. So I hope, oh, I forgot that I haven't got a last slide. I hope that in some way I've given you a reason to think that all of those horrible things, and they are horrible, like the fact that legacy holds us back, the fact that we've got some terrible wrong defaults in our code, there is a plus point to it. Now, it's not necessarily C++'s real superpower, but I do genuinely believe that the stickiness of C++, the fact that we're all sat here talking about it so many years on, is because there's a sort of unbroken line back 30 or 40 years of code that we have and can just bring in and use. So thank you, everyone, for listening. Thank you to Rob Snell, who's my co-collaborator on this and was my university housemate back in '95. Hannah did all of the pictures that you saw that were any good. The sources on GitHub, if you want to go and laugh at where it is right now. There is a beta that you can connect into mudzania.org 9000, and then maybe your code will still compile in 2046. And how terrifying would that be? Thank you all.